Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in the previous class, we had finished the important problems of NCERT exercise. So in today's class, we'll be starting with the next new chapter, which is called as Determinants. So first of all, we'll have a very quick look at the introduction. So what are determinants, students? So previous chapter, what did you study? We had studied the matrices, right? Yes. So in the matrices, we saw different types of matrix, correct? Row matrix, column matrix, square matrix, rectangular matrix, symmetric matrix, skew symmetric matrix, and so on. So different types of matrices we had seen. In this chapter, what are determinants first of all? Determinants we can see to make you very easily understand what is the meaning of determinants. Determinants are like far relatives of matrices. But determinant is only applicable to square matrix. Alright. So for example, if you take a square matrix, so we'll take a matrix here. Okay. Yeah. So here, if you take a square matrix, A equals determinant of, square matrix A11, A12, A21 and A22. What is this? This is a square matrix. How do we call it as a square matrix? Because the order is 2 cross 2. So what is the standard way of representing an order? M cross N, and if M is equal to N, then we call that matrix as what? A square matrix. Okay, so this is a square matrix. So you have done many things in this, right? Addition of matrices, subtraction of matrices, multiplication of matrices, division of matrices, row transformation. So whatever you do with the matrices, what were we getting finally? We were getting a matrix only, correct? Now what is determinant? A single value of this, a single value of especially a square matrix. So determinants is only applicable to square matrix. A single value of a square matrix is called as a determinant. So we'll see the definition of determinant here. To every square matrix, point to be noted, to every square matrix Aij of order n, means what? M is equal to n, right? So of order n, we can associate a number. So this square matrix will be having a single number. So let us take 3. Just an example. Okay. So if you find out the determinant of this matrix, you will be getting the answer as 3. Okay. Can associate a number real or complex. So sometimes real, sometimes complex. Called as the determinant of the square matrix. Now students, how do we represent a matrix? The matrix can be like this. Matrix A is equal to square bracket A11, A12, A21 and A22. Now how do we write the determinant? So matrix is written like this, right? Within the square bracket, here also within the square bracket. Determinant, how can it be written? Simple, students. So 2 straight lines, that's all. So this is called as determinant A. Determinant of A, or sometimes we also use det of A. These both are used to represent the determinant of a matrix. And how are the elements written inside the determinant? Again, straight line A11, A12, A21 and A22. This is how we represent a matrix, and this is how we represent a determinant. Understood what is the meaning of determinant? Once again, it is a very far relative of a matrix, okay, which will associate a single value or a single number for the given matrix. So in matrix, whatever you do, you will be getting matrix only as an answer. But in determinant, what will be getting? A number you will be getting, either real or complex. But this is only applicable to what? A square matrix. So this is introduction to determinants. How do we represent determinants? This is how we represent, and matrix is represented like this. Alright. So moving on to the next one. we'll be seeing how to evaluate the determinants. So square matrix I said you, right? So see here students. So you can also go further, but that will become very, tedious. Okay, the process will become more tedious, means more complex. So it will require more than 15 to 20 minutes to solve the determinant of order 4 cross 4, 5 cross 5 and all. Okay, so for your syllabus for class 12, we are only restricting it to order 3, which means, so we'll begin from the beginning. Evaluation of the determinants. So evaluation of determinants of order 1 means what? Here the order is 1 cross 1. Square matrix, right? M should be equal to n students. Square matrix. Understand? Determinants is only applicable to square matrix. Okay. So next, evaluation of determinants of order 2, which means 2 cross 2. And evaluation of determinants of order 3, which means 3 cross 3. So you can go further, 4 cross 4, 5 cross 5, 6 cross 6 and so on. But to solve all these higher order determinants, what will happen? The time required will be more. Okay, it will take around some more than 30 minutes to solve 6 cross 6, 7 cross 7. So in your syllabus, we are only restricting until here. These are not included. So we are only studying which all students, evaluation of determinants of order 1, order 2 and order 3. So these are the orders. So we'll start with the very first one, evaluation of determinant of order 1. So for example, a matrix is given, a square matrix is given. Okay, square matrix A of order 1 cross 1 is given. So what is the matrix given here? Let us take 3. What is the determinant of this matrix now? Determinant of A is equal to 3. Understanding? So generally what can we write? If a matrix A is given as A, so this is the element of matrix A of order 1 cross 1, right? 1 cross 1, square matrix, M is equal to N. So what is the determinant of A? Determinant of A will be equal to A. Very simple, whatever is given, that will be the determinant. So this is for order 1. Understood students? So this is very simple, very simple. This is whatever is given in the matrix, that will be the determinant of that particular matrix. So determinant of A is equal to the same one, 3. I hope you understood this, very simple. Let's go to the next one. Evaluation of determinants of order 2. Now students, so before we start, there is one example here. Okay, before we start with that example, on this side we'll start. How do we solve order 2 cross 2? So here what we'll do, we'll take a general matrix, generalized matrix, okay, standard form. Matrix A of order 2 cross 2. So here we'll write A11, A12, A21 and A22. Correct? So this is the given matrix. What are the elements of the matrix? These are the elements. Actually there will be numbers later on, numbers or variables or functions. Anything can be the entries of the matrix. Alright, but how do we find the determinant of this matrix now? So determinant of matrix A can be written as, so students remember, whenever you get 2 cross 2 matrix, okay, always multiply the principal diagonal first. What is principal diagonal again? If you recall, principal diagonal is nothing but AII. Correct? AII. So what is the standard form of the elements of the matrix? So these are the elements of the matrix, right? These all are the elements of the matrix. What is the standard form of elements of matrix? It is nothing but Aij. Correct? Aij. Ith row, jth column. Correct? So now what is Aii? See this? 1 1, same. 2 2, same. So how do we evaluate determinant of order 2? Multiply the principal diagonal first. What is the principal diagonal, students? This is the principal diagonal. Correct? This is the principal diagonal. Multiply that. So that will be A11 dot A22. Means A11 into A22. Now here comes the important point. In matrices, the default sign between the elements will be plus. But in determinants, so for example, A11 dot A22, right? The default sign will be negative. minus. So just remember this point. Okay, memory, that's all. So principal diagonal you multiplied first, a11 into a22 minus the next diagonal you multiply. So these both, which is nothing but a21 dot a12. So if you do this, if you simplify this, you will be getting a number, and this would be the determinant of order 2 cross 2. Understand? So what you have to do here is, you have to multiply the principal diagonal first, subtract that with another diagonal. So that would be the evaluation process or evaluation procedure for order 2 cross 2. Okay. So here we have an example. So this is one small example, students. So determinant of this we have to find out. So principal diagonal we have to multiply first. So that would be equal to how much, students? X into x is nothing but x square. What is the sign in between them? Minus. Okay. Multiply the next diagonal. So that is, it will be x minus 1 into x plus 1. Correct? So further simplify this now. X square minus of a plus b into a minus b, a square minus b square. Correct? Distribute this minus sign inside, which will be equal to x square minus x square plus 1. Plus x square minus x square will get cancelled. Therefore, determinant. So if this is given as determinant of a, so we can write determinant of a will be equal to 1, and this would be the right answer. Understood? So very simple, students. To solve determinant of order 2, first multiply the principal diagonal. Default sign is minus always. Okay. And another diagonal elements you have to multiply, simplify, and whatever number you will be getting, so that would be the determinant of the given matrix. Got it? Yeah. So moving on to the next one. So order 2 we finished, right? Order 2 we finished. So what would be our next one? Order 3 would be our next one. So before we start with order 3, what we have to do is, we have to know another concept. So which is essential to solve or evaluate determinants of order 3. Okay. So what is that concept? So that is nothing but called as cofactors. So students, what is this cofactors? I'll let you know. So we'll take. So this cofactors is, first of all, why this is used? To evaluate the determinants of order 3. Correct? We'll take a matrix of order 3 now. Matrix A of order 3 cross 3. Okay. Matrix A of order 3 cross 3. So what would be the elements of this matrix? A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. So what is the standard way of representing the elements of the matrix? The standard way of representing the elements of the matrix is A, I, J. Now what are these cofactors, students? Okay, now I will represent cofactors with red color. Okay, just have a look at that. Plus, minus, plus, minus, plus, minus, plus, minus, plus. These are nothing but what? So whatever you can see in red color, those are called as what? Cofactors. Understanding? Those are called as cofactors, which means nothing but the signs above each and every element or entry of a matrix. So these are the cofactors of the given square matrix. So cofactors are also present in 2 cross 2 matrix as well as 1 cross 1 matrix. Okay. But how are we getting the signs? To understand that, what we'll do is, to get the signs of this matrix, we are using minus 1 whole to the power of I plus j. Understanding? Minus 1 whole to the power of I plus j. Now if you want, what is the cofactor of A11? If someone asks what is the cofactor of A11, how do you tell? A11, right, which is equal to minus 1 whole to the power of, what is I? See what is in the place of I? In the place of I we have 1, so write 1 plus. What is in the place of j? In the place of j also we have 1 plus 1, which is equal to minus 1 whole to the power of 2. So minus 1 whole to the power of 2 is nothing but plus 1. Correct? So this plus We got it here. Understanding? Moving on to the next one, let us take a minus sign. So let us take A32. Alright. So what is the cofactor of A32? So write that A32 equals minus 1 whole to the power of, what is in the place of I? 3 plus, what is in the place of J? 2. So that is nothing but minus 1 whole to the power of 5. Correct? So that is nothing but minus 1 into minus 1 into minus 1 into minus 1 into minus 1. So minus into minus, plus, minus into minus, plus, plus into plus, plus, plus into, we have this another minus which is equal to minus. So therefore this would be the cofactor of A32. Very simple, students. So to just generalize this again, okay, we can write it like this. Minus 1 whole to the power of odd is equal to minus 1, and minus 1 whole to the power of even is equal to plus 1. Now add them both. 1 plus 1 2 even, plus 1 plus 2 odd. 1 plus 2 is 3, right? And 3 is odd, so we got negative. 3 plus 1 4 even, positive. 2 plus 1 3 odd, and so on like that. So even, odd, even, odd, even. Understood what is cofactors? How do we find out the cofactors of any element? So this is the formula to be remembered. This is the formula to be remembered. Minus 1 whole to the power of 1 plus j. Now let us see for 2 cross 2 matrix. So 2 cross 2, what do we have? Matrix A equals A11, A12, A21, A22. So write the cofactors of these matrix, students. If you try writing 1 plus 1 odd, 1 plus 1 2 even, plus 1 plus 2 3 odd, minus 2 plus 1 3 again odd, so minus 2 plus 2 4 even, plus. So these are the cofactors of 2 cross 2 matrix. Understanding? So you have to remember this formula for cofactors. So why did we go to cofactors? Because this is used to evaluate the 3 cross 3 determinants. Okay. So let us start evaluating 3 cross 3 determinants. So here, evaluation of determinants of order 3. We'll take one example, students. So here is the example. Now, we'll write the cofactors first. So before, see, no need to write the cofactors of all the elements. So whichever row you want to expand the determinant with. So I'll tell you how do we find out the determinant here. So we'll write, first we will do what? We will evaluate the given determinant with respect to first row. With respect to first row. So with respect to first row means for the first row you have to write the cofactors, correct? Because you are evaluating the determinant with respect to first row, right? So for the first row only you have to write the cofactors. For other rows, no need to write the cofactors. So what are the cofactors of first row? Plus, minus, plus, correct? So this would be the cofactors of first row. Now try to evaluate this. So how do we evaluate, students? Understand? Plus 1, plus 1. Now what will happen? This plus 1's column and plus 1's row is gone. Okay, this is how you have to evaluate 3 cross 3 determinant. So plus 1's column and plus 1 row is gone. What is remaining? Here we got the determinant of 2 cross 2. Find out the determinant. First multiply the principal diagonal. 0 into 3 is 0. Okay, open the bracket here. 0 into 3 is 0. What is the default sign in between them? Minus. 1 into 0 is 0 again. Finished. Plus 1 is done. Next you have to go to the minus sign. So we'll erase this. Okay, so this will be gone. Next what do we have? Minus 2. So write minus 2 as it is. Minus 2. Open the bracket. Now once you write minus 2, what will happen? This is gone. The row is gone. And the corresponding column is also gone. What is remaining again? 2 cross 2 matrix, 2 cross 2 determinant is remaining, right? Multiply the principal diagonal first. 0 into minus 1, 0, minus 4 into 0, 0. So now minus 2 is also done. Erase that. Okay, next, plus 4 as it is, plus 4, open the bracket. So plus 4's row and plus 4's column is gone. What is remaining now? 2 cross 2 determinant, 1 into minus 1, minus 1. What is the default sign in between? Minus. What is 4 into 3? 12. Understanding. Further simplifying this, 1 into 0, so this is becoming 0, right? 0 minus 0 is 0, 0 into 1 is 0. So again 0 minus 0 is 0, into minus 2, so even this will also become 0. What is remaining? 4 into minus 30. So 4 into minus 30. So this would be equal to how much, students? Minus 52. So this would be the determinant of the given matrix or the given question. Okay, minus 52. Okay, students, did you understand this? So we got minus 52 if we evaluate the determinant with respect to the first row. Now you can evaluate the given determinant with respect to the second row. Okay, with respect to the third row, with respect to the first column, with respect to the second column, with respect to the third column. Also, in all these cases, your answer will be minus 52 only. This will not change. So now we evaluated with respect to the first row, right? And we got the answer as minus 52. You can also evaluate the same question with respect to second row, third row, first column, second column and third column. The answer will remain same. That would be equal to how much? Minus 52. Okay. So now what we'll do next is we will take first column in the next trial. Alright. So see here, same question, no changes with respect to the first column now. Okay. With respect to first column. So we'll be a little bit fast now. So what would be the, so this is A11 plus, this is A21 minus, this is A31 plus again, correct? So this would be plus 1. So these both are gone. So we are getting 0 minus 0, correct? So next would be minus 1. So here the cofactor is minus, right? So minus of, what is the number there? Minus 1, minus of minus 1. So if these both are gone, 0 into 2 is 0, minus 4 into 1 is 4. Okay. Next is plus 4. Plus 4, open the bracket. So 0 into 2 is 0 again, minus 4 into 3 is 12. Evaluate this. So this is becoming 0. So this is becoming plus 1 of minus 4, correct? Plus 1 of minus 4 plus 4 of minus 12. So plus 1 into minus 4 is minus 4. Plus 4 into minus 12 is minus 48. So minus 48 minus 4 is equal to how much? Minus 52. Same answer we are getting, correct? So no matter with respect to which row and which column you are expanding, you will be getting the same answer. But what we are going to see in this slide is, so students, whichever row and whichever column you take, you will be getting the same answer. No worries in that. But the smartest way to consider is the third column. I'll tell you why. Why should we consider only the third column? Why? Because in the third column, see, we got 2 zeros. Correct. In the third column, we got 2 zeros. So here, we'll be evaluating this determinant with respect to third column. So let us write the cofactors of third column. This is A13 plus, this is A23 minus, this is A33 plus again. So you see here now, plus 4, okay. So what will be remaining? 1 into minus 1 is minus 1, minus 4 into 3 is 12. Now next would be what, students? Minus 0, that's all. 0 into anything. So minus 0 means this and this is gone. 1 into 1 is 1, minus 4 into 2 is 8. So no need to do this at all. No need to do this. Why? Because 0 multiplied into anything will be 0 only, right? So no need to do this. And again we got 0. So plus 0. So this is 0. This is also 0. So directly you can write 4 into minus 13, which is equal to minus 52. So students, the smartest way to expand the determinant is to see in which row or which column we have maximum numbers of 0. So with respect to that, if you try to expand the determinant, the time taken will be less. Understanding? So that is all for today's class. We had seen what is the introduction of determinants and evaluation of determinants of order 1, 2 and 3. We'll be meeting in the next class again with the next topic. Until then, take care. Please do like and subscribe to Vista's Learning. Thank you.